My name is Raffaella, and I lead global innovation and market strategy for Accenture Extended Reality.
Good morning. My name is Patrick Costello. I lead North American business development for Qualcomm's XR business.
So at Accenture, we believe that there are 4 emerging technologies: quantum computing, extended reality, distributed technology ledgers, and artificial intelligence that really our clients and any company have to be able to adopt and utilize in order to compete in what we define as the post-digital era. The Accenture Extended Reality Group specifically is responsible for identifying and creating XR solutions. So not experiences, but full-fledged solution architecture. What does that mean? That we work with roughly 90% of the Fortune 1000 clients across all industries. So we look at the value chain of different industries, and when we identify areas of challenge, we try to apply an XR lens to that. And we try to see, can AR or VR, or a combination of the two, help solve for those problems? If we think that the answer is yes, we pilot that solution with our partners and clients, we go to market with that, and then we figure out a way to build it at scale. Another thing that we do, and we believe strongly in, is that the growth of the XR market is tightly connected to the growth of the 20 or so strategic ecosystem players. So whenever we do this type of new offerings, we make sure that we are connected and we work with partners and clients. And one of those is Qualcomm.
Thank you. So I never like to take for granted that anyone in the audience really knows Qualcomm or what we do, but just we're a leader in mobile, widely kind of considered the R&D engine for the mobile industry. If you've been following the news recently, you've may have noticed that we're also kind of a major force behind accelerating the adoption and deployment of 5G recently. So we like to stay on the edge of innovation, and we strive to do that, which is why we're investing so heavily in XR technologies. We do believe that XR is the next evolution of the human mobile computing platform that will eventually scale to smartphone-type volumes. But at the end of the day, we don't make consumer electronic devices, right? We make the technology that goes inside the devices. So when we endeavor to build a new category like this, it's really important for us to pick partners that we can go to market with. And for us, it was just a no-brainer to team up with Accenture. They're on the front lines of dealing with Fortune 1000 enterprise companies. That's a segment that we don't touch directly. So they're in the trenches. They understand the pain points, the use cases, the requirements, and they ultimately end up building end-to-end holistic solutions for their customers, which is, I think, a good segue into the project.
So what we're going to be discussing today is VR merchandising and the offering we created around that. But before I even do that, I wanted to at least explain what merchandising is. At a very high level, merchandising is the art of maximizing sales in store by doing different things. You could change pricing, you could change packaging, the positioning of a product, or the store flow. And brands and retailers perform hundreds and sometimes thousands of those tests every year. So it's an expensive and time-consuming activity. The other thing that they have to do is they actually have to collaborate and agree on what the ultimate result is, and then they have to make sure that there is compliance in store. So whatever they decide, that is actually being reflected in store. So it's a bigger undertaking that maybe we think when we walk through a store. So if we had to break down the 8 major studies, one of them is new product placement. So if there is a new product, where do I put it, within a category or within a shelf, to make sure that I maximize the sale for that product, but I don't cannibalize the sales of other products. Planogram or SKU rationalization. So do I have too many of a specific SKU? Should I have a different combination of that within the entire store or within a category? Pricing and promotion. If I change the price of a specific item, or if I apply a promotional pricing of some kind, does that actually affect sales, and how does that affect sales in store? Signage or display and advertising. So not only the positioning of that specific sign within the store, but also what is the message and what is the creative, and which one performs better. Packaging. If I change the packaging, will they actually pick it up more? Will they see it? Will they not see it anymore? How does that affect sales? The overall shopper decision tree. If we follow shoppers through the store, can we see how they end up making purchases and why? the store flow itself, if I modify certain physical elements of the store, or I position categories or shelves or things in a different part of the store, does that actually change and reduce sales or increases sales? And finally, qualitative research. Can I gather qualitative research to then decide what additional studies I want to perform? So if you think about all of these, traditionally the tests have been run either in a physical environment, so either you find that testers are brought into a physical store and then you follow them, or you might bring them to mock-up stores. Often CPG or retail companies create stores across the world where they bring testers to see how they act and what they do. Another way of doing it is really in 2D, so online surveys, online tests, in-home user tests. So if you think about that, you would have to come to the conclusion that it's a highly manual process, because every time you have to change something, physically you have to go and recreate it or modify it. It's slow and expensive for the same reason. It does take a while to modify a physical environment. It's also expensive to move testers and participants to a specific geographical location. It's limited in depth and reach for the same reason. If you want to get a sample of testers that is geographically dispersed, it's a little bit more difficult to do. Also, it's more difficult to gather behavioral data, particularly if you're doing it online. And lastly, it's difficult for the retailers and the brands to communicate and collaborate. So it's difficult for them to be able to see the same data, agree on what the optimal solution is, and at the end of the day, making sure that there is compliance. So what we wanted to do is we wanted to, again, apply an XR lens and create a new solution, a new digitally enabled process that goes from the creation to the evaluation to the communication of that specific process. And what we created is a VR merchandising offering. So as I was saying before, for us, it's not really all about selling services, but it's about selling an entire solution and making sure that that solution can be built at scale efficiently. So when we do that, we look at the different parts and the different pieces of products, so to speak, that fit within that solution. And we identify them and we create it as a package. So in this specific case, we had a VR merchandising content platform that allowed us to swap 3D environments and 3D assets faster, and that was in Context Solution. We use an eye tracking analytics platform that was Cognitive 3D. We use a 3D content creation pipeline set up on purpose to make sure that assets were created in an efficient manner and distributed within the organization in an efficient manner. And finally, we chose specific hardware manufacturers from the VR side. Having said that, we will walk you through the case study of the project that we did. So at the beginning of the year at CES, we launched a project that we did with Qualcomm and Kellogg's. And the project dealt with one of those 8 studies that I was showing at the beginning. So it only dealt with new product placement within a shelf. So that's what you're going to see. Let me give you a little bit, kind of like a summary of what that was. Then we will show you a video that gives you the full story, and then we will break it down for you. If you have any questions, we'll be happy to answer them. Kellogg's is a client of ours, and they were launching a new product, Pop-Tarts Bites. They had already done traditional testing, and they had determined that consumers expected to find new products higher up on a shelf, where you see it in the image. So what we did is we recreated the same test plus an additional scenario. We created a VR environment. Specifically, we wanted to create an environment using a VR mobile headset with eye tracking. So in order to do that, we used the Qualcomm reference headset powered by the Snapdragon 845 with embedded eye tracking from Tobii. And we let shoppers just shop as they normally would for Pop-Tarts products. And the 3 things that we were looking to do and get to were, could we do these type of tests faster and cheaper at scale? Could we prove that there is a high degree of correlation between the results of traditional tests and those of VR merchandising? And then could we get behavioral data through eye tracking that maybe would modify our decision, and that decision maybe would be better? The answer to all 3 was yes. And specifically when it came to eye tracking, What that did for us, it allowed us to get to a more holistic answer. Specifically, during testing, we were able to show an increase in sales, total brand sales of 18%. So if you bear with us, we'll show you a video. If I can play that, that is.
Product placement and assortment in a store and on a shelf isn't just guesswork. Using scientific evidence to understand consumer buying behavior helps both brands and retailers maximize opportunity to drive sales. So we wanted to use technology, and specifically VR or virtual reality, to reinvent how brands gather consumer data and perform research, allowing them to do it faster, more affordably, and at larger scale. Kellogg's was launching a new product, Pop-Tarts Bites. They needed market data to determine placement, assortment, and the marketing strategy in store. Traditionally, this data would be gathered via an online service or in-home user tests. And while these methods do provide valuable insights, we knew mobile VR and eye tracking could provide additional data with fewer logistical concerns.
Qualcomm partnered with Accenture to create a more effective solution for this kind of market research. By using our mobile VR platform, we're able to give researchers more flexibility in their testing with the potential to deploy to a wider range of testers at lower costs, but most importantly, with greater functionality. The headset is powered by our latest and greatest flagship processor, the Snapdragon 845. It supports full room scale positional tracking, but even more impactful for this project is the integration of the latest eye tracking software from our partner Tobii, giving us the ability to precisely track where the user is looking with a very high degree of accuracy.
We worked with In-Context Solutions, a VR merchandising platform, and Cognitive 3D, an eye tracking analytics platform, to create a virtual supermarket complete with aisles and store shelves and virtual products to fill the shelves.
Using a mobile VR solution, unencumbered by restrictive heavy cables, liberates the user to tour the virtual supermarket while the eye tracking technology is doing its job, giving us the new layer of valuable data about the shopper's attention and focus.
Studies have shown that shopping in virtual reality closely reflects real-world behaviors. With a virtual store, it's much easier to quickly alter variables like placement, assortment, or signage to test different configurations and then see how those changes impact purchasing outcomes. And when gathering data for Pop-Tarts Bites, we knew what the traditional methods had already shown, and that is that consumers expect to find new products higher up on a shelf.
So in our first testing scenario, we placed the product on a high shelf and added promotional signage and captured shoppers' eye movements as they looked at virtual shelves. We can see their eyes were drawn to the sign and nearby products. This even helped visibility of other brands placed above the Pop-Tarts Bites.
In our second scenario, we placed the product and sign on a lower shelf. And sure enough, again we observed users' eyes were drawn to the sign and the nearby products. But more importantly, we saw that the placement increased attention to the other surrounding Pop-Tarts products. So while we were able to confirm the high degree of correlation between the results of our VR tests and those from existing testing methods, eye tracking also provided us insights in consumer behavior that otherwise we would have missed. And that led us to a different merchandising conclusion: to place the Pop-Tarts Bites in a lower position, resulting in an increase of total brand sales of 18%.
So using state-of-the-art mobile VR hardware powered by Snapdragon and embedded eye tracking, we are able to generate more useful data and better insights,
resulting in improved speed, scale, and costs of market research for our CPG and retail clients.
So again, you can find this online. If you just search for Qualcomm, Accenture, virtual merchandise, you can find this, and there is also a POV that gives you more information about it. But again, if we were to break it down, really what we did is we recreated the store in VR. We recreated the exact shelf in VR. When I say exact, what I mean is that exact proportions, exact SKUs, and even the exact placement of the competitive products. And then we just let shoppers just go at it the way that they normally would, and having a mobile headset allow them to move around freely.
Thank you. Let's provide a little bit more data on the eye tracking analytics. As Raffaella mentioned, we actually integrated the Tobii eye tracking technology into our reference hardware. So we put the cameras inward facing. We actually surrounded the lenses with some LED illuminators that actually illuminate the eye, and of course the Tobii software is working. All that data then being sent up to the Cognitive 3D platform, ingested for dashboarding purposes. This is one example, a quick reference, a heat map that shows you at a quick glance where people are looking for how long. But the granular data that's available at this platform level is much deeper than that. So you can actually look at, gaze ratios, where people are looking versus other objects in the scene. Obviously, gaze count, so how many times did the user go back to that particular item and look at it. But more importantly, correlative data on user behavior, right? So in the experience, the user can go in and actually pick up objects off the shelf with the controllers. They can put it back on the shelf, or they could check out with that item and actually buy it in the experience. So you can correlate all that behavior, user behavior data with the eye tracking data, which becomes really useful for key decision makers in the process. Couldn't resist of course, for this project, the eye tracking was used in a pretty straightforward way. What are people looking at, for how long and how often? But I wanted to just highlight a few other use cases for eye tracking technologies, because it is more of kind of a Swiss Army knife. You may have heard something called foveated rendering. That's reducing the rendering workload on the system by reducing the sort of the image quality on the peripheral of where the eye is looking. This has very material system benefits, performance benefits. There's an increase, I think, importance and usage of avatars. Digital avatars are going to be used in the XR space as they get more photorealistic and devices are more pervasive in the market. Having more realistic interactive eye contact between, for example, in a telepresence use case between avatars can be really important. If you have a VR HMD today, you might have one that has a manual mechanical adjustment for IPD adjustments, because everyone's pupils are a different size and everyone has a different face shape and head size. So eye tracking can be used to actually kind of automate that process using the software. Of course, biometrics, this could be a really important enterprise use case. So having authentication when the user puts on the headset to get them behind the firewall using eye tracking. And then you can actually dial in performance of things like gesture tracking, controller tracking by using that eye tracking input as another data stream to really get some fine-tuned optimization. Really quick on how kind of Qualcomm goes to market, because I think this project really illustrated sort of in a really microcosm way how it can be effective. So of course, we provide the core silicon and software to our customers. But that comes with specialized advanced algorithms. In this case, it could be eye tracking or foveated rendering. We could sort of bundle that up. We have what's called an HMD accelerator program. So you might be an ISV or IHV or a new sensor company or a camera sensor or an IMU sensor or controller. We might take that, onboard that, test it, certify it, evaluate it, make sure it's working well with the platform, and then we provide all of that sort of as a package to our OEM partners. And that ultimately helps them accelerate time to market for their end consumer devices, which you see many of those on the right. So in this case, it worked very well because we had eye tracking we wanted to showcase. We partnered with Accenture, we highlighted the use case, and now we have OEMs adopting eye tracking in their commercial devices, which will be coming at the end of the year. The next 10 years, we believe, will be defined by the confluence of 5G, XR, and AI. Virtually everything's going to be connected at fiber-like speeds, at the low latencies that 5G promises. AI will be driving a lot of the perception, some of the things like object detection, scene understanding, which are happening today. They'll take all the inputs from on-device processors, contextual information, environmental processors, hopefully only presenting contextual information, relevant contextual information to the users at the exact right time. Mapping it back to a project like this, sometimes it's fun to do a thought experiment, right? So maybe in 10 years, this sort of study won't be done offline. It won't be done with a controlled study. Maybe in the ultimate commercialization phase would be people are walking into a grocery store now. We might have to make a big supposition that grocery stores still exist in 10 years, I don't know. But as you might get presented with an opt-in as you walk into the grocery store, and you're wearing your smart glasses. Do you want to provide your metadata to Ralph's in exchange for some benefit that maybe Ralph's wants to give you back? So as you're going through your shopping journey in the store, all of that metadata is being sent up to the platform, being aggregated, anonymized for Ralph, so that maybe at the end of the week or the end of the day, they get a report from the system that says, here's how you can tweak or optimize your store layout to maximize the benefit for the business. It could be for customer traffic flow. It could be for maximizing revenue. It could be for maximizing customer satisfaction. But that's how it, maybe practically it could be implemented in the future. So just the last slide. Well, first of all, thanks everyone for coming. As Raffaella mentioned, all you have to do is search VR merchandising, Accenture, Qualcomm. Raffaella authored an excellent point of view case study on the project, so I'd encourage you to go download it and read it. And if you have any questions, we'd be happy to answer them. Thank you.